Good morning, dear students. I welcome you all for the third part of your unit number 5 of refrigeration and air conditioning. In this part, we will deal with the air handling units, that is air transmission and air distribution system. See, in the last two parts, we have seen the different air conditioning system, their working principles, and one thing which we have observed that whenever your cooling load requirement is below 25 TR, you must go for unitary air conditioning system, and if the cooling load is more than 25 TR, you must go for the centralized air conditioning system. See, whenever the cooling load is more, obviously the air which has to be handled by your refrigeration plant, that also increased. As per the standard specification, if your cooling requirement, cooling load is about 1 TR, okay, so in that case the air has to be handled is about 400 CFM, okay, that is cubic feet per minute. That's the unit of airflow. So if your cooling capacity is of 1 TR, you will have to handle, that system has to handle 400 CFM of air. Okay, so just imagine if your cooling load is increased more than 25 TR, let me say it would be 100, it could be 200, it could be 250 also. Okay, whenever you are going to cool or whenever you are going for air conditioning of a large spaces, big buildings, okay, in that case the cooling load would be beyond 100 TR. So for an example, if you are having 250 TR, so for 1 TR it is 400, so for 250 TR it is around 1 lakh CFM. Okay, so when this kind of a quantity of air you need to handle, you must have to go for the proper designing of air handling unit. Okay, because your system has to handle this much quantity of air, 1 lakh CFM, that's approximate around 50,000 liter per second. Okay, this much quantity of air you need to handle, and for that particular air handling you must have a proper air handling unit. The proper distribution has to be takes place after proper transmission, and in order to avoid such conditions, in order to make the system simple, sometimes depending upon the cooling load you can go for the chilling plants also. Okay, chilling plant, centralized air conditioning unit. Okay, where your centralized air conditioning system, your particular cooling plant or refrigeration plant, it is kept at the basement of the building, that there is a room where there would be a compressor and there is an evaporator. More precisely we will call it as a chiller, that is a chilling plant. Okay, I'll show you that sketch, that could be easier to understand. Just wait a minute. Okay, now here you can see this chilling water or chilling plant of centralized air conditioning system. In three parts we have divided this. The top part is dealing with your condenser cycle, the center part that deals with your VCR cycle, and the last part that is about your air handling unit. Okay, in this case, this is the part which is of the refrigeration cycle, that consists of compressor, water cooled condenser, expansion device, and direct expansion evaporator, that is DX type. So in this case what is happening is that your refrigerant is flowing through that compressor, water cooled condenser, expansion valve, and then your evaporator. In evaporator, your low pressure, low temperature refrigerant, it comes in contact with the water which is coming out from this cooling coil. Okay, this cooling coil, this is simply an heat exchanger, you can say. Okay, through the coil there is a flow of water, and over the coil there is a flow of air. This air, that could be mixed air or the air which is coming from outside, that is fresh air. In mixing box, your return air which is coming from the air conditioning room and the fresh air which is coming from your outside atmosphere, they will mix and they will send to that particular heat exchanger, this one. There it will going to get mixed and it is flowing over the tubes through which the water is flowing, that is a chilled water. This water is get cooled in this evaporator, that is DX evaporator. So you can simply say that the water is used as secondary refrigerant. Okay, and the water which is available in your water cooled condenser, that is as a cooling media, it is circulated through this particular cycle, that is water cooled condenser cycle. Okay, the heated water that sends to your cooling tower, which is located at the top of your building at the terrace, there that hot water would be sprinkled and it would be get cooled, and again it would be supplied back to your water cooled condenser, and the cycle would remain continuous. Okay, and the lowermost part, that is of your air conditioning system, after getting the cooling effect, after producing the cooling effect, this cooled air, now it is gets supplied to your air conditioned space through your air distribution and air transmission system. Okay, and again the cycle would goes on continuous. So this can also be a way to have the centralized air conditioning system by using the chilling water. Okay, now we will move towards the air handling unit. Okay, now we will discuss about the air handling unit. Now air handling unit, its main function is that it has to transfer the processed air, it has to transfer the conditioned air from air conditioning plant to the conditioned space and distribute it uniformly. Okay, that is the most important thing. I told you earlier, again I'm repeating, whenever you are dealing with any air conditioning system, along with temperature and humidity, third important thing along with the purity is circulation of air. Okay, if you have conditioned the air properly, you have maintained the temperature, you have maintained the humidity, okay, but you have not distributed it properly, the comfort will not be achieved in that particular space. The human comfort will not be achieved. Okay, so for that particular proper circulation of air, you must have the proper designing of air handling unit. Okay, see, if we are going for up to 50 TR, you can directly use direct expansion to centralize AC. Okay, directly whatever the air which is you are planning to supply to the conditioned space, you can directly send that air, somewhat heated air, to your evaporator coil or the cooling coil. But if the cooling requirement is more than 50 TR, you will have to go for chilling plants. Okay, the chilling water centralized air conditioning system. Okay, so whichever the type you are going to follow, you must have the proper designing of air handling unit. Okay, you can see here the air conditioning system that uses air as a fluid in thermal distribution system, it is necessary to design the air handling unit properly. Okay, it has to transmit the process air from air conditioning plant to the conditioned space and distributed it properly within the conditioned space. Okay, that is the most important thing dealing with the any air conditioning system, that could be of higher capacity or that could be of a lower capacity. Okay, so the air, it has to be transferred through different passages, through different pipes. Okay, that could be called as a ducts. Okay, you can see the components also. These are the components of your air handling unit, that is air transmission system. Okay, the air from your conditioned plant to your conditioned room, it has to be transmitted through certain pipes or passages which are simply called as a ducts. Okay, these are the supply ducts or that could be return duct. Okay, the supply duct, that is transferring the air, conditioned air from the plant to the room or from room to that plant, that is a return duct. Along with this air transmission system, that is the duct system, the second thing what you are having, that is air distribution system. Now these are the openings, these are the types of different outlets which are provided in the rooms. Okay, that could be for supply or that could be for the return. Okay, you have conditioned the air in the conditioning plant. Okay, and then you have transferred it to that particular room through different ducts. Okay, and after duct, okay, now it has to get supplied in that particular room. Okay, so in that the room there could be different types of openings. Okay, again depending upon the type of flow, depending upon the arrangement, there would be different types. So these are simply an openings whose aim, whose function is to transmit this air, distribute this air uniformly, evenly inside that particular room, inside that occupied zone. Again, along with this ducts and some outlets, the important component is of your fans and blowers. Okay, the fans and blowers, they are providing the necessary energy to move the air throughout the system. Okay, for proper circulation, for proper force circulation, you must have such auxiliary which are providing energy to that particular air to move throughout that system, throughout that particular cycle, right from your air conditioning plant to your ducts, through ducts to your outlets, and from outlets to the room, and room to the return ducts, and the cycle would continually happening. See, whenever you are designing any air conditioning system, the designing of air handling unit is very essential. See, your fans, your blowers, they are consuming more power. Okay, to force that air, to circulate that conditioned air or returned air, it requires some energy. Okay, along with that, whenever you are transferring that air, when you are carrying that conditioned air from plant to the room or from room to this particular plant, you have different types of ducts arrangement. And whenever you are making an arrangement of ducts, you are consuming more space. So two important things that deals with your air conditioning or air handling unit is duct space, the space which is occupied by your duct, and the energy which is consumed by your fans or the blowers. So whenever you are designing any air conditioning system, you must have proper designing of air handling unit. If the designing is wrong, if designing is poor, your air conditioning system will not provide you the comfort values. Okay. See, as the fan consumes large power, duct consumes considerable space in the building. Hence, the designing of air handling system is important step in the complete designing of any air conditioning system. Got it? That is about your air handling unit. Consists of ducts, outlets, fans, and the blowers. Fans that is for supplying the air, that is for retaining the air. Okay, air distribution system that consists of different outlets, and air transmission system that consists of supply air duct or return air duct. Now next is air transmission system, which is the essential part and very important part of your air handling unit. Air transmission system is simply consisting of the ducts. Okay, ducts which are going to supply the air or which are going to carry the returned air. Obviously that is from air conditioning plant to the room and room to the air conditioning plant or cooling plant. Okay, accordingly you will call it as a supply duct or the return duct. These are simply the pipes or passages, you can say. Okay, by observing their configuration, their orientation, you can say that these are the pipes, these are the passages which are employed to carry that conditioned air. Okay, to carry that conditioned air properly without losing its quality. Okay, and to understand that, you need to deal with the fluid mechanics part, that is Bernoulli's equation. Okay, in order to design the air transmission system, it is important to understand the fundamental of fluid flow. Okay, that is Bernoulli's equation. That could be used whenever you are going to design any air duct. Okay, generally they are employed to supply the conditioned air to the outlets which further distribute that air in the room or in the occupied zone. From conditioning plant, from that air cooling plant to that particular duct, and from that duct to that particular room. Okay, accordingly you will have three different sections. Obviously we have already seen this part, that is these are the passage or pipes which are used for carrying and transmission of air to and from the room. It can be supply duct or it can be a return duct also. Now it classified on the different bases. You might have observed in different malls, different buildings, offices, big houses, that there is the rectangular, circular, oval or square shape. Okay, on the basis of that you can classify them. Again, on the basis of pressure and velocity, you can classify it as a high pressure, low pressure or medium pressure duct, or high velocity at the low velocity. Okay, these are the very essential parts. Related to the velocity, you must know that if your diameter of the duct is large, the velocity will reduce. And if diameter is small, the velocity will increase. Obviously, again, it deals with the pressure losses. Okay, and when it deals with the pressure, velocity, obviously it deals with the discharge, and when it deals with the discharge, again you are talking about the amount of air which is handled by your ducts and the amount of air which is required in your conditioned space. That's why its pressure, its velocity, it has to be maintained to a designed value. And whenever you are designing any duct, few things that you should note it down, that is, first one is the space which is available with you. Okay, you can't directly choose any particular shape as per your choice. You need to deal with the space availability. Okay, the space which is available in the building, the passages which are available, the passages which we can employ there, the pipes which we can install there. You need to observe the space available. Along with the space, second thing that you should know is about the noise level. Okay, the noise level should be very, very less. It should be negligible. That whenever it comes to your particular room through certain outlets, it should not create any noise or any vibrations. Again, it should not have any leakage. It should be perfectly insulated. Regarding insulation, I'll tell you one thing, that is a discoloration of wall. There is a one phenomena. There is a one thing that you might have seen in different buildings, that wherever there is an arrangement of a duct, wherever there is an arrangement of different types of ducts, you can see that the color of wall is you can say that it is somewhat disappeared. It is because of sweating of the duct. See, through the duct there is a flow of air that could be hardly 12 degree, 14 or 15 degrees Celsius. But the outside air, outside the duct, the air which is present, that would be of the surrounding ambient temperature, that could be 30, 35. Okay, if I'm talking about a hot humid conditions, hot humid weather, 35 degree, let me say the temperature, and the humidity, let me take it as the climate is humid, it would be around more than 65-70%. Okay, so let me say 35%, 35 degrees Celsius temperature, dBT, and 70% RH. Okay, so this 70% RH of air, it consists of some moisture, some water particle. Okay, so water molecules, and the temperature of condensation, that is dPT, dew point temperature, that would be around 20 degrees Celsius. Okay, so when it reaches to that, the hot humid air, it start condensing. Okay, so as it start condensing, it is forming the layer of water on the outside surface of the duct, and that water which is collected on the duct, it comes in contact with the wall and it is discoloring that wall. Okay, that is the called as a phenomenon of discoloration of the wall, if your duct surface is not properly insulated. Okay, because there would be a transfer of heat. This cool air which is at 14 degrees Celsius inside the duct, and the air which is outside the duct, that is 35 degrees Celsius, this outside air that reaches to its dPT and it start condensing. The water start condensing, vapor. Okay, so that is also one important thing, that is duct must be insulated. it should have proper balancing. Okay, so as like the conditioned air which is coming from the plant, and then it is distributed in different rooms or different zones of the building. So at that time, the particular quantity of air that should be balanced properly. Okay, it should not be like that more air or the more discharge it goes through different passages of different dimensions. Okay, so that should not be imbalance. And the last important thing, that is of the cost. So the five six things which you need to consider before designing of a duct, that is a space available, noise and vibration level, duct leakage, duct insulation, balancing of the duct, and balancing of airflow in the duct, and the cost. Now material use. The material that could be of aluminum, galvanized iron, that is GI sheets, what you can have. Always whatever the material you are using, that would be of the sheet metal type. Okay. And these are few methods for designing of the duct. That is velocity method, equal friction method, and static pressure recovery method. Now supply duct arrangement, it can be have this kind of an arrangement. You can simply see this loop perimeter duct system and radial perimeter duct system. Now this is the plant plenum and these are the outlets. Whatever the conditioned air which is produced in your air conditioning plant or the chilling plant or cooling plant, it enters to your plant plenum, and from that it is distributed through different opening to the room. This way it goes, this way, or this way. And you can see that as it is mentioned that this is a loop perimeter, so this loop is get formed. Okay, so from plant plenum, the conditioned air, it is supplied to the feeder ducts, and feeder duct, they are connected together in terms of loop, and through the outlet it supplies to your room. This is the loop. And second one is the radial parameter. In radial parameter, again there is a plant plenum which receives the cool air from the conditioning plant, and through this particular duct it will be supplied to that particular zone or that particular room. That is a radial perimeter type. Now next is this extended plenum. Again, this is a horizontal arrangement of that particular plenum, and this is the plant from which the conditioned air comes to your plenum, and from that plenum it sends to your different rooms. This is an arrangement of your extended plenum duct system. So these are the three different ways or three different arrangements for your ducts.